In this class, we're going to go over questions on velocity time graph. Okay, let's start with the first question. The diagram above represents the velocity time graph of a body in motion. The total distance traveled by the body is 195 meters. Calculate the acceleration of the body in the section OP of the graph. Okay, we are asked to calculate the acceleration of the body in this section OP. This is point O and this is point P. So we are asked to calculate the acceleration. Now, we are given that the total distance covered by the body is 195. So that's the parameters that were given. S is equals to 195 meters. Okay. Now, we cannot determine the acceleration of this section without knowing the velocity. You understand? Because when the body starts from rest, it starts from point O. You understand? Then it accelerates. The acceleration would when it accelerates, it got to point P. That acceleration is what we are asked to calculate. But it doesn't just accelerate. It attains a velocity. That velocity is what we need to determine before we can calculate the acceleration. You understand? You know, acceleration is equals to change in velocity all over change in time. Okay? So, how do we determine the velocity? The velocity at this point, we need that velocity. You understand? This is the final velocity, Vf. That is the final velocity. Now, we need to determine the final velocity that the body attains when it accelerates. Okay? Don't forget, in our previous class on velocity time graph, I told you that anytime you are calculating the velocity in velocity time graph is also the same thing as height. You understand? Hello, listen to the explanation again. When you are dealing with velocity in velocity time graph, the height of the graph along the y-axis is also the same thing as the velocity. Are you paying attention? So here, since we've been given the area of the motion, the area of this graph is 195. Are you paying attention? Please pay attention. The total distance is equal to the total area. Are you paying attention? Distance covered, distance is equal to area of the graph. Are you paying attention? Now, if you look at this graph, what is the shape? What shape do we have on this graph? The shape that we have is this is the shape. Now, what is the name of this shape? The name of this shape is known as trapezium. You understand? The name of this shape is known as trapezium. So here we have trapezium. Okay? Now, you know that the name of this shape is trapezium. Now, what is the area of a trapezium? Area of a trapezium is equals to, sorry, I'm not really good at drawing, but I want you to understand. That's why area of a trapezium is equals to 1 over 2 a plus b multiplied by h. You understand? And I told you that when you are dealing with velocity time graph, height is the velocity. You understand? Because the velocity is represented along the y-axis, so the height is the velocity. You understand? So here I'm going to have the area is equals to 1 over 2 multiplied by a plus b multiplied by vf. You understand? Where vf is the final velocity that we need. Are you paying attention? Now, the area is equals to the distance. You understand? The total distance on the velocity time graph is the same as the area of that velocity time graph. You understand? So area is what, 195 meters. So I'm going to have 195 is equals to a plus b. A in this case, A and B in the trapezium are those parallel sides that can never meet. You understand? If you look at this trapezium, this line and this line can never meet. You understand? Look, this line that you see here and this line, they can never meet. So here, these sides that are parallel to each other are known as A and B. So here we have A and this is B. Now let's go back to our velocity time graph. The A in this velocity time graph is this. So the distance from this point to this point is what? 21. You understand? So here I'm going to have 21 plus, okay, B. B is what? The distance from this point to this point. The distance from this point to this point is what? 11 minus 6. You understand? So that is what? 5. You understand? The distance from this point to this point is 5. And the distance from this point to this point, hello, from this point to this point, that is what? 21. So I'm going to have 5 plus 21, 21 plus 5 all over 2 multiplied by VF. Do you understand? If you didn't understand, listen to the explanation again, okay? Now, here we have 195 is equals to 26 all over 2 multiplied by final velocity. I'm very sure you understand what I'm doing, okay? Now, 26 divided by 2 gives us 13. So I'm going to have 195 is equals to 13 multiplied by final velocity. So divide by 13 to get the final velocity. So the final velocity is equals to 195 divided by 13. That will give us 15 meter, 15, okay? That means 15 meter per second because velocity is measured in meter per second. Now, having gotten the final velocity that we need, so we can easily determine the acceleration of the section OP according to the question, okay? At the acceleration of section OP. Now, acceleration is changing velocity over time. So, acceleration here is equals to change in velocity all over change in time. Acceleration is equals to, now, VF minus V initial, that is change in velocity. That is the difference between the final velocity and the initial velocity. The final velocity is what? Is 15 meter per second. So here I'm going to have 15 meter per second minus the initial velocity is 0. You understand? So here I'm going to have minus 0 all over change in time. So the the final time is what? Is 6. Don't go and use this time. Oh, hello. Don't go and use 21, okay? Because we are asked to calculate the acceleration of the section OP. You understand? So don't go and use this. Don't go and use 21. Use 6. You understand? Because that is the time it takes to accelerate from rest to the point P. Do you understand? So the final time is 6. So I'm going to have 6 minus the initial time is what? 0. So I'm going to have 0. Okay? A is equals to 15 all over 6. Acceleration is equals to 15 divided by 6. What's the answer? 15 divided by 6 is 2.5 meter per second. So acceleration is a meter per second squared. So I'm going to have 2.5 meter per second squared. Do you understand? Okay. Now let's say the question says we should determine the acceleration of the body. That will be 15 change in velocity, which is Vf minus V naught, divided by change in time 21 minus 0. You understand? So you're going to have 0.71. Do you understand? But we are only asked to calculate the acceleration of the section OP. Do you understand? Okay, so the acceleration of the section OP is 2.5 meter per second squared. Okay, so that is the solution to the question. Okay, let's look at question number 2. The diagram illustrates the velocity time graph of the motion of a body. We are asked to calculate the total distance covered by the body. Okay, now look at this velocity time graph. On this velocity time graph, the total distance is the same thing as the area of the graph. Don't forget, okay? When you talk about the distance on the velocity time graph, the total area of the graph gives the distance. You understand? So we are given this velocity time graph as the graph that illustrates the motion of that a body undergoes. You understand? So the area that we have, the area of the shape that we have on this velocity time graph will give us the total distance. You understand? So now let's calculate the area. Please kindly pay attention. Solution. That is question number 2. Now on this velocity time graph, we have 3 shapes. Hello. On this velocity time graph, we have 3 shapes. The sum of the area of these 3 shapes will give us the total distance traveled by the body. You understand? So the first shape is this, the second is this, and the third is this. You understand? So let us take it step by step. Okay? Now, the first shape is this shape. The shape, let me give it a letter. Let's call this shape A, B, C, D. You understand? So the first shape is A, B, C, D. Okay, so here we are going to have something like this. A, B, C, D. Do you understand? If you didn't understand, listen to the explanation again. It's simple, okay? Now, you can see that the shape that you have here, the shape that you have here, what is the name of the shape? The name of the shape is a trapezium, you understand? Having known that the name of this shape is a trapezium, now let us label the side. You can see that from this point, this is small letter, okay? Let me write it in small letter so that there will not be confusion, okay? Now, from this point, this is AC. This should be C and this should be D, you understand, okay? Now, let us label the side. From this point to this point is what? Is 10, you understand? Because this point is 0.0. Now, the body moved from 0 velocity to 10 velocity. So, from this point to this point is 10. So, I'm going to have 10 here. From this point to this point is 5. You understand? That is 5 seconds. So, I'm going to have 5 here. From this point to this point, if you trace it to the velocity side, you are going to discover that it is 20. Are you paying attention? This represents the height, and along every graph, height is measured on the y-axis. You understand? So, if you trace this from this point to this point is 20. How do I know? I trace it to the corresponding value along the y-axis, which is the velocity. You understand? So here is 20. So this side will be 20, and AB. Now we have labeled the side. You understand? We don't have any value for this side, which is AB. That's not the problem, okay? We have gotten all we need to calculate the area of the trapezium, you understand? And area of the trapezium is given by this formula. Area is equals to half multiplied by A plus B multiplied by H, where A plus B is the sum of the parallel side of the trapezium. Parallel lines are lines that cannot meet, you understand? So you can see that this is one, this line and this line cannot meet. That means that they are parallel side, you understand? So here we are going to have area is equals to 1/2 multiplied by 10 plus 20 multiplied by 5, you understand? Height is the 5. The height is the 5. You see, you can redraw this trapezium as this. You can redraw it like this. We are going to have something like this. We are going to have something like this, where, please pay attention, where the longest side is B, D, then we have A, and we have C, you understand? So you can see, you can redraw it like this. You can see that this is exactly how a trapezium look like, you understand? So you having redraw it like this, you can easily determine the A. The A is the parallel side, which is this and this. That is 10 and 20. You can see this will be 10 and this will be 20, and CD will be the height, which is height, you understand? And with this you can easily determine the area of the trapezium. Do you understand? So now all you have to do now is that you just have to add 10 and 20, that is 30. 30 divided by 2, that is 15. 15 multiplied by 5, that is 75. You understand? Let me erase this. So the area is equals to 30 all over 2 multiplied by 5. Okay, that is 15 multiplied by 5. 15 times 5 is 75. So this is 75. Now, because we are dealing with distance, so we are going to put it in meter. Okay, so now that is the first section on this velocity time graph. Now let us proceed to the second section. On the second section we have B, and the shape is like this. This is how the shape look like. You can see, you have to pay attention to the shape. This is not a square, you understand? It's a rectangle. Okay, you can see that the lengths are not the same. The length of this and this are not the same. Now we have, okay, let us call this one as well, letter A, B, C, D. Let's call this one E. Let's call this one F. Okay, so we have B, D, E, F. Okay, now please pay attention. You can see that the shape that we have is a rectangle. Area of a rectangle is what? Length times breadth. Okay, so let us label the side. BD is, what is the length of BD? The length of BD is what? Is 20. You understand? I've already explained it. The length of BD is 20. And how do I got 20? I trace the height from this point to this point, I trace it to the velocity side. I trace it to the velocity side, and what is the corresponding value at that point is 20. You understand? So let me even redo this. This is where it should be. So the corresponding value of the velocity at that side is 20. So the length of BD is 20. So this side is 20, and now DF is what? DF is what? DF will be 10 minus 5. Are you paying attention? Hello? The distance between this point to this point will be 10 minus 5. 10 minus 5 is what? 10 minus 5 is equals to 5. So the distance between this point to this point is 5. How do I got 10? The final distance is this. Okay, the final time is 10. The second, the initial time is what? Is 5. 10 minus 5 is 5. So the distance between this point to this point is 5. Are you paying attention? So DF will be 5. Now, we've gotten all we need to calculate the area of the rectangle. So area of the rectangle is equals to what? Length times breadth. Okay, the length is 5 and the breadth is 20. So here we're going to have 5 times 10, 5 times 20 is 100. So here we have 100 meters. That is the area of the shape. That is the area of the rectangle. Okay, now let us proceed to the last shape. The last shape, we have a triangle. You understand? And let's just draw it. Let's draw it out. Okay. Here we have something like this. We have something like this, and you can see that will be EF. Let me call this place G. Okay, EFG. E, F, and G. Okay. Now, from this point to this point, the difference is what? 15 minus 10. 15 minus 10 is what? That is 5. So the distance between this point to this point is 5. That is the time. You understand? So the time taken from this point to this point is 5. Now, that means that FG is 5. And EF is also the same thing as BD. You understand? So that will be 20. So here I'm going to have 20. So area of a rectangle is half base times height. So area is equals to half multiplied by base multiplied by height. You understand? So area is equals to 1/2 multiplied by base. The base here is 5 multiplied by height, which is 20. Okay, 5 times 20 is 100. 100 divided by 2 is what? Is 50. So here we have 50 meters. Do you understand? Okay, so having gotten all the area of the shapes that we have on the velocity time graph, don't forget the area is also the same thing as the distance. You understand? So the total distance is equals to, the total distance is equals to the sum of all the area. You understand? So let us proceed. We are going to have the sum of this area, which is 75 meter, area of the trapezium, plus the area of the rectangle, which is 100 meter, plus the area of the triangle, which is 50 meter. Okay, 50 meter. So the total distance is 75 meter plus 100 meter plus 50 meter. That will give us 225 meter. You understand? So the total distance is 225 meter. So that is the solution to that question. If you have any question regarding what we've learned in this class, let me know in the comment section. Okay, that will be all for this class. If you want to learn more on velocity time graph, there is a playlist on this channel. You just have to click on the channel, go to the playlist, then watch those classes that we've already done. That will give you more, it will broaden your knowledge. You understand? When you practice more example. Okay, so if you have any question regarding this, let me know in the comment section. Okay, I'm going to attend to it. So that will be all for this class. Before you go, don't forget to like and share the video. And if you want to be part of this channel, kindly subscribe. But it is important that you like and share, because most of our videos, even though they are good, we are going to see thousands of views, but you people will not like. When you don't like the video, people that need the video will not be able to view it. You understand? So make sure you like and share the video. Okay, see you in the next class.